How do we differentiate a function to a power again? Can anyone give us the formula?
M times f, and then m minus 1 times f. I'm blanking, sorry.
Always remember times f prime. This is mandatory, right? Because if this is x, that's x times x to n minus 1, and even this one is x prime, but we don't write it because it's 1. So remember it like a tune. Make up your own. You may not want to remember my tune. N times f to n minus 1 times the inner function prime. So you make up your own tune and repeat that and repeat that and repeat that. Okay. Now here's a question for you. What happens if I have a function raised to another function? What do you think?
Would it be the function it's raised to times the first function?
Okay, so no rule. Okay, it does not exist. So let me start with an example. Let's say x raised to cosine x. So the question is asking us to find the derivative of this function. There is no rule for something like this. Remember here, n is a number. N, a number, not a function. N is a number. Yes?
Quick question. You said there's no rule, it does not exist. Does that mean that an answer doesn't exist or the rule doesn't exist?
The rule does not exist. There is no rule for that. In other words, no differentiation rule, I meant to say. No differentiation rule. This is a differentiation rule. It's called the power rule. We have the product rule. We have the quotient rule. We have the chain rule. We do not have a differentiation rule for a function raised to another function, like this one. This is a function raised to another function. So what we're going to do are the following steps. Number one.
Take the natural log.
Absolutely. So this is our function, okay, without, sorry.
So we're going to take the natural log and then we're going to use implicit differentiation.
Brilliant. You want to teach this? I can sit back. Please, go ahead. So y equals x raised to cosine x is our first step, the function. In step 2, we apply natural log to both sides. So then natural log y must equal natural log x raised to cosine x. Can anyone tell us what is the log property that we will apply now?
The power
yes.
of ln x drops down.
Very good. Natural log y equals as a factor, which means cosine x times natural log x. So that's our step 2. Our step 3, diff both sides. Good. That's what I'm doing. Can anyone help? Remember, this is a function. So this is a function that is the outer, and this is the function that is the inner.
The left is going to be 1 over y times y, or dy dx.
Brilliant. That's it. That's all I want you to say. Excellent. Who was that? Aaron? Thank you. Good. Now, can anyone differentiate this product for us? And remember, we have to have 2 terms. It's the product rule. We have to come up with 2 terms. two quantities.
Sine x, natural log x.
Yes, careful,
Sorry.
it's negative.
Negative.
Yeah, yes.
Negative.
Negative sine x times natural log x. And then,
Plus cosine x.
yes, over,
times,
yeah, directly
over x.
That's it. Brilliant. Thank you very much. So plus cosine x divided by x. No one can simplify this. Forget it. Don't even look at it. I need to solve for dy over dx. What should I do to both sides to get dy over dx by itself?
Multiply by y.
Good. I will multiply by y, but I will not write y. I will write x raised to cosine x. So x raised to cosine x. And now I uncover and copy everything. Negative sine x times natural log x plus cosine x over x, and it's done. You don't have to do anything else. This is it. That's how logarithmic differentiation works. Can we apply it in other problems? Oh yeah. Not necessarily a function raised to a function, but I think we should practice one more. So let's practice one more.
Why do we change 1 over y to x raised to the cos x? Was y like just a placeholder, or why did we do that?
But if I use this or I use this, does it make any difference?
Oh, I see. Okay, thank you.
But I don't want to use this because I don't really want to have two different situations here. I want to have just x. It's not a mistake to keep it as y. Even y is okay. But it's the derivative of y with respect to x. If I can avoid having y here, I should always. And since they are the same, I want x raised to cosine x. Is that better?
Yeah, much better. Thank you.
Perfect. Okay, let's look at another one and practice. And then I'll show you another example in which we can use a logarithmic differentiation and it does not have a function like this one. So let's say tangent x raised to 1 over x. I'll let you choose between these two. Natural log x raised to cosine x. Whichever you want to work on, we'll start on that one.
The second one.
You want to start with the second one. Good. Okay. So since we had power cosine, can I change it into something else? You change it into anything you want. So we are making one up. So it's natural log x to whatever. You can put tangent, you can put 1 over x, you can put the square of x, you can put whatever. Just give me another function, any function you want. So we don't want this, we don't want this, we want to make one up. What would you like the power, the function at the power to be?
7.
Ellen?
Sure.
No, I mean, I just didn't hear what you said.
7x.
7x, perfect. Okay, so in step number 1, we apply natural log. So we have natural log x equals 7x, careful, natural log of natural log x. So I skipped a couple of steps here. So I apply natural log here and natural log here. Natural log y, I have natural log of natural log x and 7x goes in front. Now we are ready to differentiate. So let's differentiate. So can anyone give us this?
One over y times dy over dx.
Perfect. Now here, this is a function, this is a function, 7 can wait patiently. Okay, so forget about 7, It's a constant times a function. 7 is outside. We are using the product rule. We have to write two terms. What will be the first term?
ln times ln x.
Careful, it's not times. This is the argument of this function. So ln of ln. Good. So now I have x times, I need to differentiate this function. Slowly, cover it, think. Natural log of this prime. With your permission, I'm going to move to the next page and I'm going to wipe that out. Because then I squeeze it in and no one understands what I'm writing. Okay, so plus x.
Times 1 over natural log x, or 1
Excellent, excellent. Times this prime.
1 over x.
That's it. So please don't write this. It's here. I'm taking care of it right this moment. Good. Excellent. Great job. So these two go away, and I will multiply both sides by y. dy over dx equals 7 times natural log x raised to 7x, and this whole thing. Natural log of natural log x plus 1 over natural log x. And that's it. This is the end of this section, but as I promised, let's look at a problem in which it's not a function to a function, but we can use logarithmic differentiation. So here's an example. Any questions? I'm sorry, forgive me. Any questions on the previous one? Any questions on the previous problem? Anyone? So it's not a big deal. All I would like you to remember, not to apply any rule here. You have to go slowly, step by step, apply natural log, differentiate implicitly, blah, blah, blah. So do not get into the trap of putting 1 over x in front, subtracting 1 from the power, who knows what. So please do not apply any rule to this. You have to go through all these steps.
I have a question.
Yes?
But can you put that last sheet
Of
back
course,
on?
of course, of course.
I'm going to try to word it, but I might not be successful.
I'm sure you
So-
will.
Right here, when we have 7x times ln,
Yes?
ln x, right?
Yes.
So to where you have your finger, we're going to do the product rule, right?
Yes, because I have function 1 times function 2. However, I have 7 times the function. 7 times the function prime is 7 times the function prime.
Mm-hmm.
So now I differentiate x, I get 1. So this is the first term, so to speak, plus I have to keep x, but differentiate this. So I keep x. And now I'm asking myself, how do I differentiate this? Natural log of a function is 1 over this function times this function prime. 1 over this function times this function prime.
Okay. Actually, so I missed the 7x. I don't know why, but that's what I missed. So that's why I was confused.
Is that better now?
Yeah, I'm good now. Thank you.
And then we simplify these two. We only have 1 over natural log x. And coming back here, I have to multiply both sides by y. But I really don't want to multiply by y. I want to multiply by what y equals to, which is natural log x raised to 7x. 7 has to stay because I had it in front, waiting patiently. And then times y. and times the rest. Natural log of natural log plus 1 over natural log because these two go away. Is that okay?
Yeah, I'm good now. Thank you.
Thank you.